Hi all, Miss Gaynor here, making my second video and on my way to YouTube stardom. So let's get started on mole-to-mole conversions. The first step you want to do is to always have a balanced reaction to start off with. So to balance this reaction, I'm going to make it 2 waters, 2 hydrogens, and leave it as 1 oxygen. Now I want to say, what do these numbers actually mean? So when we call these coefficients, actually stand for the ratio of moles in a reaction. This means that in this equation of decomposition of water, that for every 2 moles of water decomposing, we're going to produce 2 moles of hydrogen and 1 mole of oxygen. So again, these coefficients actually tell us the ratio of moles. For every 2 moles of water that decompose, we're producing 2 moles of hydrogen and 1 mole of oxygen. So again, to say that these are ratios, we have the 2 to 2 to 1 ratio. That means that for every 2 moles of water that decompose, we produce 2 moles of hydrogen and 1 mole of oxygen. We can also say this as molecules. For every 2 molecules of water that decompose, we produce 2 molecules of hydrogen and 1 molecule of oxygen. But this is a really important part here. It doesn't work for grams. If we were going to put this into a ratio of grams, for every 36 grams of water that decompose, we produce 4 grams of hydrogen and 32 grams of oxygen. That's because 2 moles of water are going to weigh 36 grams. 1 mole of water using the molar mass is 18 grams, so 2 moles are equal to 36 grams. And it's the same for hydrogen and for oxygen. So make sure that if there's a 2 to 2 to 1 ratio, that does not mean that 2 grams of water are going to produce 2 grams of hydrogen and 1 gram of oxygen. Not how it works. So let's work through how we would solve a sample problem. Now we want to say if 4.5 moles of water are decomposing, how many moles of oxygen are going to be produced? So the way we solve this is just like when we did dimensional analysis. We start off with 4.5 moles of water. So that's what we start off with. That means if we have moles of water on top, we're going to want to put moles of water on the bottom. And we're converting to find moles of oxygen. So we've set up our ratio here. Remember, the numbers on top and the bottom are the same. They're equal to each other. So because we start off with moles of water on the top, we're going to put moles of water on the bottom and convert to moles of oxygen. Now we know that in this reaction, for every 2 moles of water, where there's going to be 1 mole of oxygen. So we're going to put 2 moles of water are equal to 1 mole of oxygen. Now we just multiply everything on top, divide by everything on the bottom. So we end up with 4.5 times 1 divided by 2, which is going to give us 2.25 moles of oxygen. That means if this much water is decomposing, it's going to produce this much oxygen. Let's look at another problem. Here we're told that aluminum reacts with oxygen gas to produce aluminum oxide. And we want to know how many moles of aluminum are going to react with 5 moles of oxygen. So the first step is to write a balanced equation. So the first thing we want to know is that we want to write out that aluminum reacts with oxygen, O2, because it's a Bringelhoff element, to produce aluminum oxide. So to balance this equation, we're going to need 4 moles of aluminum for every 3 moles of oxygen, and that's going to produce 2 moles of aluminum oxide. So now that we've got our balanced equation, we can set up our railroad tracks. We can set up our dimensional analysis. So this means we start off with 5 moles of oxygen. We want to convert moles of oxygen to moles of aluminum. So we set it up so that we've got, So we've got moles of oxygen on top, moles of oxygen on the bottom. And we're converting to moles of aluminum. So we know that in this equation, for every 3 moles of oxygen, that 3 up here, we're going to also need to react 4 moles of aluminum. So we set it up as 5 times 4 over 3. Remember, multiply everything on top, divide by everything on the bottom. 5 times 4 gives us 20. Divided by 3 is going to give us 6.7 moles of aluminum. What you're going to be working now are on the tiered problems in your packet. Mild problems, you're already given the balance reaction. Medium problems, you need to balance. Hot and sizzling problems, very, very hot, you're going to need to write out the equations and balance them for yourself. So choose which tier you want to start off working on, and then keep working. The answer keys are in your packet as well, so check your work as you go. Good luck and have fun!